Okay, so we're in section 7.4 here, and we'll do some more examples. The last one that we did was this guy here, and we did this one also. So remember that the first thing that we're looking for is just if we can do the problem with just a use substitution, or if we can go with the answer. You know, that's the most efficient ways. Now, a lot of these problems are not going to be like that, though. But that's still going to be the first thing that we'd want to look for, you know, just in general. This one is going to involve the method of partial fractions here. And so let's see. Of course, I wouldn't let u be the denominator, right? If u is x cubed minus x squared minus x plus 1, then du would be 3x squared. That's not going to work. Minus 2x plus 1, that's not going to work. Okay, so now the denominator has to be a factored form, okay? So just like what I was doing up here, I have to factor the denominator. So now, if I factor the denominator in this problem, I'm going to use the method of factoring by grouping. And I'm going to let the first two terms be one group, and then the last two terms be another group. What's going to come out of group 1 would be an x squared, because that's in common to these two terms. And then that's going to leave me with x minus 1. Now, to have the factor by grouping method work, I'm going to need another x minus 1 coming from group 2. If I can't get that, then factoring by grouping is not going to work out. Okay, and I got to think of some other way to factor this. If I factor out a negative 1 out of these two terms here, that leaves me with x minus 1. Okay, so x minus 1 is in common to these two groups. So let me go ahead and factor that out of the whole thing. There on the next line, that's going to leave me with x squared from the first group, and then minus 1 from the second group. Okay, x squared minus 1, that's the same as x plus 1 times x minus 1. I've already got an x minus 1. So that's going to be x minus 1 squared times x plus 1. Okay. X minus 1 repeats, in other words. So when I set up my my partial fraction decomposition here, all three of these terms are linear terms, are linear factors. So let's see, I'm going to have a divided by x minus 1 plus b divided by x minus 1 squared, because x minus 1 repeats 2 times, and then plus c divided by x plus 1. Don't forget about the fact that, you know, x minus 1 repeats. If I only had a and b, you know, here I would not get the right answer. Okay. So then the next thing is with this equation, let's go ahead and clear out the denominator. We'll multiply both sides of this by x minus 1 squared times x plus 1. That's going to leave me with 2x squared minus 5x minus 1 on the left. And then a times x minus 1, that'll cancel. That's going to be with one more x minus 1 times x plus 1. Okay, plus b times the x minus 1 squareds will cancel. So b is being multiplied by x plus 1. Plus c times, there's the x plus 1 will cancel. This x plus 1 here. And this will be c times x minus 1 squared. Okay. So when I simplify this guy here, I've got ax squared minus a, and then plus, here's a cx squared minus 2xc plus 2. Okay, so a plus c, both of those terms have x squareds tacked onto them. Okay, so I'm going to go ahead and factor that out of the whole thing there. And then the next term here, we got, let's see, it's going to be bx, and then minus 2cx. So minus x, that's minus 2cx. Okay, b minus 2c, that's in common to these x terms, so let's go ahead and factor that out. Okay, and then plus, here's negative 1 times a is negative a, okay, plus b plus c. Yeah, that's going to be the constant term there. So then the next thing I'm going to do is I'm going to match. Okay, a plus c has to go with 2. B plus 2c, or b minus 2c has to go with negative 5. And negative a plus b plus c has to go with negative 1. Okay, so from that, I create a system of equations that I'll need to solve here. Well, let's see, to solve this system, if I leave the middle equation as I see it, I got that right there, and the first and the third equations, let me go ahead and add those together. So a minus a, that's 0. 0 plus b is b. And then c plus c is 2c. 2 plus negative 1 is 1. Okay, and that is going to help reduce this to a 2 by 2 system. So then if I add these equations together, b plus b is 2b, 2c plus negative 2c, that's 0, and then 1 plus negative 5, that's negative 4. So 2b equals negative 4 means that if I divide both sides by 2, b is negative 2. Okay? Knowing that b is negative 2 means that I can plug that number into any one of these equations and find c. So I'm going to have negative 2 plus 2c equals 1. If I add 2 to both sides, 2c equals 3. Means that if I divide both sides by 2, c is 3 halves. Okay, and then if c is 3 halves, and I subtract 3 halves from like this first equation here, 2 minus 3 halves is 1 half. So a is 1 half. Okay, so it looks like a is 1 half, b is negative 2, and c is 3 halves. And I'm going to go ahead and plug in those numbers in the right side of this equation here, and where I see a, b, and c. And of course, make sure that your integral notation looks good. You know, we're integrating this. Okay, so this integral for 2x squared minus 5x minus 1 divided by x minus 1 squared times x plus 1, that is equal to 1 half times 1 over x minus 1 minus 2 divided by x minus 1 squared, okay, and then plus 3 halves times 1 divided by x plus 1. Okay, well, I can go ahead and split up this integral then into 3 integrals. Also, I can bring out the constants there. And the first and the third integrals, I'll be able to know what those are right away. Just the second integral here, that would involve a u substitution. If I let u be x minus 1, du is dx. Okay, so I'm going to have a minus 2 times the antiderivative of 1 divided by u squared, that's u to the negative second power, du. Okay, and the answer then, I got 1 half times the ln of the absolute value of x minus 1 minus 2 times u to the negative first power divided by negative 1. Negative 2 times negative 1, that's plus 2. And then u to the negative first power, that's 1 over u. U is x minus 1. Okay, so be plus 2 divided by x minus 1 plus 3 halves times the ln of the absolute value of x plus 1, then plus a constant. Don't forget about the absolute value bars again. That's totally necessary. We need those. Okay. Let me start in on this problem here next. So I again, the first thing that we're always looking for is just if we can use the u substitution, or if we can get the answer. You know, that's the best situation possible. Okay. Don't forget about the comparing the degree of the top to the degree of the bottom. Okay. So the degree up top is 2. The degree down under, let's see if I foil this back, I'd have an x cubed term down under. Okay, whenever the degree of the top is less than the degree of the bottom, then I'm going to use the method of partial fractions here. I'm not going to divide. Okay? So let's see, I got 6x squared minus 3x plus 1 divided by 4x plus 1 times x squared plus 1. 4x plus 1, that's a linear factor. X squared plus 1, that's a quadratic factor. So where I see the quadratic factor, I'm going to want a bx plus c. Don't have just plus b divided by x squared plus 1. That'll get you wrong answer. Okay, so again, whenever we have a quadratic term, you always need an ax plus b, or in this case bx plus c term in the numerator. Okay, now again, we need to find a, b, and c. Okay, so the next thing I'm going to do with this equation here is let's go ahead and multiply both sides of it by 4x plus 1 times x squared plus 1. That leaves us with 6x squared minus 3x plus 1 on the left, and we got a times the 4x plus 1 terms cancel, so the a times x squared plus 1 plus bx plus c times the x squared plus 1 terms would cancel times 4x plus 1. Okay, so then the next thing is I'm going to group the x squared terms together, the x terms together, and the constants together, and then I'm going to match things on the left with things on the right. Okay, so I've got ax squared plus 4bx squared. Okay, that's, if I factor out an x squared from those terms, that'd be a plus 4b times x squared. And then, let's see, the next thing, so I have plus bx plus 4cx. Well, if I factor an x out of those terms, I got b plus 4c times x. And then the constant terms, got plus a plus c. Okay, so then the next thing I'm going to do is I'm going to match those things with the constants on the left. Okay, so a plus 4b has to go with 6. B plus 4c has to go with -3. A plus c has to go with 1. Okay, and then now we got to solve this system. So let's see. I guess if I let me use the first and the third equations there, and if we subtract those, then the a's are gone, right? A minus a is 0. You got 4b 0 minus c, that's minus c, equals 6 minus 1 is 5. Okay, and then we'll leave the middle equation just as is there. Okay, and so I've reduced this to a 2 by 2 system. 2 equations with 2 unknowns. Okay, the unknowns are b and c. Okay, so then the next thing, let's get rid of b. Well, if I multiply the bottom equation here by -4, and then I add these 2 equations together, here's 4b minus 4b, that's 0. Negative c minus 16c, make sure you distribute, that's negative 17c. And then 5 plus 12 is 17. Okay, divide both sides by negative 17, so c is -1. And by the way, for these problems here, keep in mind that A, B, and C, and D, whatever these letters are, they're not going to be oddball numbers. Okay, it's not going to be 503 divided by 87 or something like that. It'd be like, C is 4 or whatever. So keep that in mind. Okay, so let's see. C is -1. Knowing that C is -1 means if I add 1 to both sides, A is 2 then. And then if A is 2, and we subtract 2 from both sides, 4b equals 4, means that b would be 1 then if we divide both sides by 4. Okay, so A is 2, B is 1, and C is -1. So the next thing I'm going to do is I'm going to replace A, B, and C with the actual numbers here. And so, I'm going to have the integral for 2 divided by 4x plus 1 plus 1 times x is x minus 1 divided by x squared plus 1 dx. Okay, and so that's where I'm at right now with this. The next thing is let's go ahead and split up this fraction here into 2 more fractions. Okay, and also I'll bring out the 2 that's a constant in the first integral. So the next line I'm going to have 2 times the integral for 1 divided by 4x plus 1 plus the integral for x divided by x squared plus 1 minus the integral for 1 divided by x squared plus 1. Okay? Let's see. So the first integral is going to be an ln type thing here. So let's see. If I let u be 4x plus 1, du would be 4 dx, right? So you're going to have a 1/4 coming outside the new integral involving u. We've already got a 2 out front there. So 2 divided by 4 is 1/2 times the antiderivative of 1 over u du plus on the second integral, if we also use a u substitution, I'm calling this t though, t is x squared plus 1. Well, dt would be 2x dx. Okay, so 1/2 dt is x dx. I got an x dx in the numerator. So it's going to be plus 1/2 times the antiderivative of 1 over t dt. And then minus, I'll just keep this third integral as I see it there. So then the answer here will be 1/2 times the ln of the absolute value of u. U is 4x plus 1 plus 1/2 times the ln of the absolute value of t. T is x squared plus 1 minus tangent inverse of x. So the derivative of tangent inverse of x is x squared, is 1 over x squared plus 1. Okay, and then plus a constant. So this here would be the answer. Okay, fun stuff, right? And again, you know, I will always know if I have the right answer. If I'm unsure about any of this here, I take a derivative, and I should get back to the integrand, which is this guy inside here. Okay, so we'll go ahead and stop the video at this spot, and I'll do this last example in the next video.